It's all lies. It's an April Fool's joke. Or is he really here? I don't know. Well, I do know because I'm, Oh man. So this is a very last minute thing. This stream will be very. How are you doing? It's not going to be very serious. I think I'm going to solder a board. But other than that, I have no clue. Oh. Just getting a Coke. Cool, Richard. 15 meter plus installs, that's nice. Oh. Announcement worked too. The Dr. Z's Discord too. Woo! Nice. Yeah, so this is going to be really laid back because I'm not feeling too great. And the girlfriend actually is testing positive for corona and has been sick for a few days. My self-tests are coming back as if I don't have it, but I do feel like crap. But I was sitting on a couch and I hadn't done anything the whole day. It was like, I'm going to solder a board. And it was like, it's my normal live streaming time. Let's hit the button, see what happens. Oh, you're using 12 volt supplies and buck converters every 5 meters. Makes life much easier. Yeah, that's awesome. Good evening, Dave. Do you think people really aren't pushing the button because they think it's an April Fool's joke? I guess so. It's the first time ever we're doing a video and a live stream on the same day. Plug your girlfriend into a dig quad and see if she brightens up. I don't think so. I'm not allowed to go near her because, she's got the Ronas and officially I don't have yet, although I feel like shit. So, who knows? Let's test that WLED controller from unboxing first. I've been debating about that, if I really want to do that or not on stream. Because I don't want to be seen just bashing someone else's product. I mean, it's fine for what it is. It's not how I would build it, but that's not the only way to build things. So, I mean, I don't know. I'm going to focus on the dig quad for this stream, I think. And maybe we'll do a stream at some point where we, we test out the other controller and see if it lives up to its specifications and stuff like that. So not today. We are curious too. Yeah, I know, but am I the one to bring you unbiased content on someone else's controller? I mean, I can say I'll be unbiased, and well, the thing I thought of was like, okay, if I do it on a live stream and I show you all the tests and you can see the results live, how much bias is there? I mean, would that be fair enough? Or would people still say, this guy's biased? Hello, ladies and gentlemen. Hello, Johnny Bergdahl. I like that one announcer voice that Unexpected Maker has. It says, Johnny Bergdahl. Well, yeah, of course. I even with my own things, I'm like, let's plug it in to see if it blows up. So, I mean... Drahtstahl. What surprise this? Party, party, party. Yeah, I'm not feeling very partying. But, we'll see how far we get. If I feel like crap too much, you can always hit the stop button. Just know it'll be a less energetic stream than normally. Yeah, but there's the thing, Draadstahl. If I'm testing it, I will share my opinions about it. I mean, if I do a test like, say, run 10 amp and flip that relay 10 times, and it does it or it doesn't do it, you know, I'll say something about those results. So then it's not unbiased anymore. I mean, yeah. You're out at 10 though. Wow. Okay. Is there a better stream going on at 10? Are you doing a new board this year? Yes, maybe. No, maybe yes. Does that answer your question, Black Dave? I'm working on some stuff. Let's just say that. There was a pink background? I didn't even notice. Hitting a bar! Damn. I did last week, and now my girlfriend has corona, and I feel crap. Like crap. So, you know, be warned. Yes, it answered my quest. We got all confused. Good, good. Yes, those are the best answers. I need to tilt my camera slightly. There we go. Hello, Adam Bryant. Right, so I guess I should start, you know, doing things. I'm completely disorganized. Let's get my 0805 components, because those should be on the DIY. Let's hope I did that. I'll be right back. And then I have my box, which I call, it's quite heavy. It's a box called the Current PCBs box. But I'm not going to show you what's in there, because there's things in there I'm not ready to share yet. So, yep, this is what we need. Okay. So I got a question recently on the unboxing video of today, actually, how I organize my stuff. And, well, there's multiple ways. If there's stuff I use really often, I have these 3D printed, not in focus, 3D printed boxes in which you can put, you know, SMD tape, and you can pull the little plastic part here, and then they just come out, and you know, you tap it out or you pick it up, and those I use for components I use a lot, basically, right? So there's three categories. There's I use a lot, there's I use fairly frequently, and then there's I don't use that often. And for the fairly frequently, I guess I could show you. We're just going to go haywire this stream. Don't mind me. So let me take this camera. Hold on. So recently I did that, which there we go. See those boxes there? Those all have a certain value of components. So capacitors 0805 or capacitors 1206 or resistors 0805 or level shifters, serial stuff, all that kind of stuff. Let me put you back. Nope. Something like that. Yeah, good enough. So I use those boxes for my frequent stuff, and yeah, that's kind of how I do it. I have lots of drawers here, And the drawers on this side, you've seen me open those. Those all have these little IKEA boxes in there, and this is a box with diodes. And this is a box with SMD LEDs. And a box with PTCs or, well, all kinds of other stuff I use frequently, basically. So, yeah, that's how I organize stuff. Link to those magazines. Wow, you're quick, Johnny. Nice, thank you. Oh, you've heard alcohol kills the virus. Nice. Show us the box of pink LEDs. Well, the background randomly turned pink. Does that count? I hope that counts. So, how am I going to solder this? Oh, right. I need an IBOM file. Let me generate one real quick. Because I'm not sure I have one of this version. So often I say on a live stream, I'm not prepared. Well, this live stream, I really am not prepared. So, PCB layout. I think it's this one. Nope. There we go. Oh wait, this computer doesn't have IBOM installed, does it? Nope. Okay, I have to install IBOM in KiCad. One moment. Yeah, oh, you use those magazines yourself. Yeah, I found that, especially for the components I use a lot, it's too much work for stuff I don't use a lot. They're great. They're excellent. I mean, yeah. Anything that I don't use that often, I just keep in the bags I get them in, and I label them. So, yeah. So let's see if this now works. Yep. Hold on. Generate. Okay, I've got my file. Oh, wait. Yep, that should be good. Hold on one moment more while I prepare some stuff. Oh, my chat disappeared. There we go. Hey, Philip is here. Too surprising. Yeah, I kind of, you know, notified no one. Right, so let me see how I'm going to do this. Okay, yes. Now let me window capture it. Okay, so we want this view. And then we want this guy. Yeah, I don't think that'll be readable, is it? Flying to Vegas for a week-long conference. Damn. Get me the bomb before I get out of the airplane. What? I haven't left Sweden since COVID started. We'll go to Berlin in a month, though. Finally. Cool. Hello from Belgium. So we have a nice little PCB here. Let me get a little bit closer. There we go. And this should be, it's behind the chat. So this should be V1 revision 1, V3 revision 1 DIY. Cool. Yep. And immediately I noticed something that I need to add. So I'm going to get my notes open. Oh, wait. You just saw all my notes, didn't you? Oh, no! Okay, well, let's see if there's anything important in there. I guess not. I don't know. See, this is what happens when I don't feel very well. I share way too much. I don't think there was too much in there. I don't know. I guess you guys got lucky. No. Oh, Martijn Vos is here. Martijn Vos is actually my brother. Like, my real-life brother. Yeah, so I'm trying to do a live stream here. Well, I'm not feeling that great. But we'll see. We'll see. So, okay. Let's just, start doing things again. And act like the note sharing never happened. That way people don't get suspicious something did happen. Okay, we need a soldering surface. There we go. And, well, all the fun stuff is on the back. Yeah. See, I still don't know how to keep the BOM file on the screen while being usable. Did I ever turn the music down? Yeah, I did. Oh, I know what I'll do. What if I put the BOM file beneath the chat? Well, then both isn't readable anymore. This is a great idea. Yeah, let's not. Okay. We stopped testing here, so nobody knows if COVID is up or down. Damn. Well, Philip, this is the first one we're testing, so I did note the ones you tested recently last week. Yeah, I could share the iBomb. That's true, and then people can follow along. But then again, that iBomb is out there, and people will confuse it with the real one for the one that's released, and chat right under, iBomb left up. Really? Do you think that's going to be better? So chat right under. Okay. And then the iBomb over here. But then it's still not really visible. I mean, I don't need, I'll crouch a little bit like this. I'll stay below it. I guess I could make it even bigger. Yeah, I guess that would work. So now you could at least read the component. One smaller? Yeah. No, one big. Okay. Okay, so now we can read the component, and what's going on here? This isn't working as it should. Okay, iBomb's drunk. I guess this would work. So can you guys read like C2, C3, and then see somewhat on the picture where it goes? Oh, I'm surprising everyone with my surprise stream. Cool, okay, let's do it like that. And then I can keep everything on screen over there. Okay, the chat looks stupid if it's not at the top. There we go. So we're moving this here. And I'll try and work over here. Okay. So who watched the Quinbox? Because, I mean, someone actually commented, I believe, like, I'd love to see him soldering wearing the slippers. Well, I'm wearing the slippers. They're awesome. Because suddenly it was like t-shirt weather outside. I'm always in a t-shirt, but you know. And then it decided to start snowing. Not sure what's going on there. But we'll just act like all is fine. There's no world apocalypse. Well, there's no world apocalypse. There's a pandemic, but you know. I should watch the Quinbox. Yeah, exactly. Now you're missing all the fun about the slippers. No, it's okay. Okay. Turned on all the soldering equipment. Nope. Not soldering. Doing abdominal training, crimping 6-gauge lugs. Yeah, we'll do that some other time. No, I didn't slip. And we're officially doing Dig Quad DIY V3 prototype today. Saw the vid. Can't wait to see you try out the Atom WLED device. Yeah, still debating that one. We talked about it a little bit earlier, but yeah. Well, that's the idea, Martijn. It's full of random parts I buy. And then maybe you buy one too. Or don't. I mean, you can just have fun watching it. That's fine too. I hope you have one of each slipper on, though. Sorry to disappoint there. I'm not that far gone yet, okay? I'm not feeling great. I'm not like... I haven't lost my mind. Although, it could happen one day. Let's see what else we need. We need solder wire. Okay, and we need tweezers. Well, you don't have to buy anything every time. I mean, you don't have to buy anything anytime. Only buy stuff you need. Don't buy anything you don't need. That's useless. Right. Well, we'll start with the SMD components, I guess. One very important step we shouldn't forget, and I'm going to annoy you guys with it, is desolder fume sucker. Because that needs to happen. You know, I've got this guy, and it sucks away all these solder fumes through this pad. Although the pad might need replacing at some point, but I think it's still good. Okay, so let's turn that on. There we go. Hope the noise isn't too bad. Time to call and wake up my drinking buddy. He works nights, so sleeping until now. Damn, okay. Then I will stop watching Quinbox. Yeah, you can watch Quinbox later on, or you can watch this later on, but this is live. Live. Yes. So the first component is one I don't have here right now, and that is an optional 1206 capacitor, which can help the voltage converter on the output. Could we get an 0805 on there, I wonder? I guess we could try that. That'd be fun. I'm gonna solder an 0805 2.2 on there. Just because I can. And I kind of want to try it out because this is kind of an optional pad. You don't need to do that. Previous designs didn't have it. But there's other DC-DC converters out there which might benefit from having extra capacitance on the output, basically. So now it says 100 UF. I'll change that because that's a ridiculous value. But yeah. So that is supposed to be down there. Okay. There we go. What do we need to share? There we go. That's one side tacked on. And it's also kind of to demonstrate, I guess, that even though this is a 1206 pad, you can get a 0805 on there, no problem. So even if you don't have a 1206, you know, you can solder a one size smaller generally is no issue. Yep, that should do just fine. So, we can tick that one off. Oh, I have to turn that on. Placed. Okay. And then we get an 0805 10 UF, and we need one. Okay. Yeah, we're doing full manual because this is the DIY, so I expect people not to have the stencils. I mean, you can get a stencil, but you don't have to for this one. So, you know. I might be messing around more than normally, but we'll see. That should do. The trick is to buy his boards before they go out of stock. Yeah, but see, only so many people can do that trick. Okay, we need 0.1 or 100 NF. Okay. What? We need to get them ASAP? It's getting near Christmas? No. We're working on boards. I actually got shots today from my partner in China where they got the new PCBs in. So they are currently going to assembly. So it's going to be, 2 weeks or so, and they'll be back in stock. Oh no, don't push the mouse. It's an issue because I can't keep my preview window and my iBomb open at the same time. But trying to make this work. Okay. Oh, okay. Here's another note. I have 2 capacitor values in there. It takes 6 months to get the lights up. I'm ready. Damn. Okay. Okay. 6 months. How long does it take to take down? Because if it also takes 6 months, just leave them there. I might want a more closer up view. What do you guys think? Yeah, we need a more closer up view. Hold on. I'm gonna undo the length on it. In my very professionally automated studio here. There we go. That's better. Yes. Okay. So next up is this guy. Oh wait, I already got it. What? It's Friday, girls start sending messages? Okay. That should do okay. Okay. Oh wait, something I guess I could do. No, that's not what I wanted. There. That works better. Cool. Okay. Okay. We did this guy. Another 10 UF. We already had it. Okay, I really need to consolidate all the capacitors and such. See, this is how you see this is still a work in progress, because otherwise I would have done all those things already. There we go. What? Speaking messages? Good evening. Quinder is wearing his brand new slippers. Yes, I am. Here it is. But now I have cold feet, so I'm putting it back. I don't even know what's going on in chat. It's okay. Okay, we're past the capacitor phase, seems, and now we need resistors. And here we have a choice, because we've been doing a lot of experimenting with resistors and stuff like that, of course. And we've basically landed on that 33R is best if you're using 3-wire cable, and 249R is best if you're using 2-wire power and then 1-wire data. So for now, we're going to go and solder the 249 on there. But since this is DIY, you can solder any value you'd like on there, or rather, which is most appropriate for your situation. Okay, so those go over there. And I don't actually have 249R here. Interesting. Okay, I'll have to get... Oh wait, I'll have to get my box. Hold on. Because I have a box called Resistor 1206-0805. $200 ohm. Oh, I guess that's close enough. Oh, I don't have any 249s left, it seems. Maybe I used them all. I'll use some 200 ohms. That is close enough for doing this one. No, the level shifter is on the dig quad. So you don't need a level shifter for a dig quad because it already has level shifters on there. Right? Okay, let's tin these pads. There we go. These quads have been a lifesaver for me, easy to use than other confusing boards. Yeah, I try to make them as logical, well, as I see them. Or logical in a way as I see it. Okay. So the Ethernet ESP version will work on the current DIY dig quads, but you'll lose the fourth channel, and you can't run 12 or 24 volt LEDs in the normal way. But with the V3 DIYs, those will be fully compatible. So we did those. We need to, let's see, 4 10Ks. There. Let's see where those go. Oh, okay. These are actually optional, but we can solder them on, that's fine. Shouldn't we need 5 10Ks? Huh. Oh, right. There's another one here. Need to consolidate that one. Where is that on the board? Not seeing it. Oh, here it is. Yeah. Okay. So we need another 10K. There we go. There we go. Are we talking about Johnny's bar life? This is an educational stream, not a dating site. That is very correct. I'm actually not sure if a good soldering skill will make picking up girls easier. I've never tried telling a girl I've just met, like, hey, you know, I solder my own PCBs. Hey. I'm not sure that's PCBdating.com. No? Is that registered already? So let's see. The 10Ks are on there. There we go. Wanted to improve those. There's one more I want to improve, and then we can move on from the 10Ks. Very interesting idea, Quinn. Yeah, I mean, I'm not sure there'll be many. There might be enough males there, but not enough, females. Who knows? Quinder, you just used the wrong hashtag on your stream. I did? Oh, man. This is why I shouldn't do things when I'm not feeling great. What did I put? Let me see. Announcements. Oh, I did everyone. I don't know. There we go. Yeah, dating while soldering might work. I don't know, man. I don't know. I've never really met a female who would be like, yeah, that'd be awesome. I mean, yeah. I guess they're out there. I'm not saying it's not possible. I'm just thinking it's gonna be quite a niche, basically. You know? You're doing a lot better than when you're feeling great. What? Yeah, 4.7K is also in there twice. I need to consolidate this bomb. That's clear. I stopped making notes because if that note is in there once or twice, I'll check it for everything. So. Okay. You could make one, yeah, but you know, would you rather me make a dating site for people who like to solder, or building and designing boards? I mean, you know, bigger components. Okay, seems all capacitors and resistors are done. So we're moving on to diodes. Diode time. And we need 6. This is 12. You can have both. You're multi-talented. Yeah, but not multi. I have enough time for everything. Ish. Whatever. 1, 2, 3, 4, 5, 6. Come on. Okay. No one tried that niche, so go for it. Victoria's Secret established was what? Okay. I don't know about that. Okay, let's do the diode part on this side. I actually forgot something. Normally when I solder, I put on my fancy glasses. There we go. I forgot them this time. Okay, let's turn the board sideways. Try and make sure everything is visible. There we go. Now these diodes are the first polarized part, so there's little stripes on there, and there's little stripes on the board to indicate where the stripes go. So then, what would our URL be called? Would it be PCBdating.com? That sounds the best. Or like DIYerdating.com? DIYerdating.com. That sounds horrible. Where did you guys meet? We met on DIYerdater.com. What? Okay. One diode lost. I'm sure we've all had this on PCBdating.com. You're holding your component in your tweezers, you get distracted, and suddenly no more component. Wherever you searched, it's gone. Okay. No, let's try and search. Nope. Giving up, getting a new component. It's not worth it. We met on Quinled.com. Well, that's a very niche market there. I mean, do they all have to date me? I'm kind of already taken in that regard. So it's going to be your big disappointment.com. DIYGF.com. No, that looks like something else, Philip. I'm not sure people should go there. That's not good. That's not good at all. Oh no, this one, I caught it using my hand, or my arm. Okay, now we solder all the other ends. I'm going to use another tip for that. There we go. Now we got the bulky chip tip. Okay. Okay, this solder wire doesn't want to do what I want it to do. Okay. That should have done that. So, we did all the diodes. And now we need some 1812 PTCs. Okay. So, I need to get my PTC box. And they need to sustain about 1 amp. Mailbags with unboxing slippers, a dating stream. What of a first April is this? Exactly, right? Let's see here. 1812. Six, 5, 63. Oh, 10. Where did I put them? 1812. 1.5 amp. No. 1.95. There we go. 1.1 amp, 1812. That'll do fine. Have fun, Joni. Thanks for sticking around. Ask her about PCB soldering if she's into that. I mean, you know, who knows? Who knows? And leave it behind in a comment when you get back. If she was into it or not. I don't know. Maybe not ask that on a first date or whatever date it is. I don't know. I'm not sure that'll end well. Market research. Oh my god. Okay. Okay. Let's redo the first side real quick. There's way too much solder on this tip. There we go. There. That should make a good connection. If you guys can even see. There we go. Another component done. Oh, we need the PTC box again, because we need a 1206. Sorry. Whoa, there we go. Oh, I found our missing diode. Well, it's going in the trash now. Let's see, 1206, 1 amp, 750. Do we have a 750? Yeah, we do. And it's these guys. There we go. Get in the bag. Okay. Do you think the girls are better at soldering than the guys? I guess it's possible. Let's see here. In there. There we go. Would a 1.1 on that place also be fine? Because on the A in Penta... Oh yeah, sure, that's fine. It's just to limit current in a overcurrent situation. Basically when a short circuit or something like that happens, that we don't blow a track or a trace or something like that. So 1.1 or 750, it doesn't, you know, as long as it's not, you know, 5 or 10 amps, that's fine. That's fine. Okay, next one done. Oh, that was the whole back of the board. Yeah, looks like it. It's not pretty, but it'll do. Okay, then there is 2 components on the front of the board, or 1 at least, because there's the LED. I think there's only the LED. Let me check. Front. There's a 1206 blue LED. Yeah, the rest is all through hole, so... Okay, let me get a 1206 LED. Not sure why I made these 1206. Probably just to make it easier. Should I make those 0805 too? No, this is orange. Oh, I guess I could put orange on there. That's fine. I mean, that's the thing about building these DIY boards. You can put any color LED on there you like. So mine is going to be orange. Yeah, 1206 is easier with LEDs. That's probably what was my thinking too. And most likely it's like... sorry. It's like that already on the current boards, so I probably just kept that. Now, ground should be on this side. And, well, that pad is already tinned because it shares a pad with the other side. And some solder bled through. So it should go this way around, because power comes in on this side and then flows to that side, which is ground. So we need to flip this around. And, oh, I need to flip my hands around. And then we need to do this. Okay, flipping hands around again. Yeah, this tip is a bit too big for soldering LEDs, but I think it worked. Oh no. Ah. Okay. So, we can cross another one off the list. Wait, where did he go? There we go. Okay, so this one is done. That's the LED. And now I need to solder in order of height. I think that is the level shifter first. So that's this guy. Let me see where I have my level shifters. I think over here. No. Oh wait. Okay. And then there is a notch here, which is always important, of course. But first I'm going to bend the pins a little bit to make it fit a bit easier. There we go. And then it fits in easily. Level shifter, fuse holders, header pins, terminals, fuse. Yeah, right. Philip recently built one, so he knows the order from head. So it's important to have the notch on the correct side, but I think we do. We can just turn that around. Solder one of the pins. There we go. See if that's in flush, but I think it is. Yeah, that looks fine. Okay. And I'm just gonna use this giant soldering head. Okay. Yeah, you can use sockets. There should be enough height clearance for that. Should be no problem. I generally don't, but it's okay. I mean, you're building the boards, whatever you want to do. Okay. That looks fine. So we can cross that off of the list. Then I believe indeed it is fuse holders. So we need 5 fuse holders. Four, 5. If you build them yourself, including the ESP, I think you're looking at $15 to $20. And if you buy it, it's $37.50, I believe, from head. But it really varies where you source the components and for how many boards. Because if you want to build 2, generally you have to buy the components per 10 or 50 or 100. And if you buy an AliExpress, you can get out cheaper than the pre-assembled. But if you buy on Mouser or DigiKey or something like that, they'll probably actually end up more expensive than the pre-assembled ones. Okay, so I put the fuse holders on there, and let's see if I can flip it around. Yeah, that worked out. I just need to shimmy the board. Let's get one of these. Got a random wire here, which, oh no. See, I didn't shimmy it on time. Nope, we have to do it again. Okay. This should be about the same height, so I'm just jamming something on the other side. No. That's not going to work. Let me get another fuse holder. Why did you have to replace the level shifter, Brett? Damn it. Yeah, I often do the flipping trick, but try to do it without now. Bad decision. So now I just shimmy one on the other side. That should keep the board straight. Okay, well, we still have the chunky soldering tip. So I'm just gonna do one of each for now. So I want to make 100% sure that they're in straight. Yeah, this T3A soldering station is great. It has so much power. Okay, so now they should at least stick in. And let's see if they're in straight, but that looks fine. Ah, your brother put 12 volt on a 5 volt jumpered board. Yeah, that's gonna kill it, for sure. Yeah. But it should indeed mostly kill the level shifter, I think. Well, it might also kill the ESP. You could get lucky, but most often it will. Okay, so that went in fine. So now I'm going to solder the rest. Yeah, that's one of the advantages the pre-assembled boards will still have, because those have my custom DC-DC circuit on there. So anything from basically 4.5 to 24 volts on, the board will survive that just fine. Whatever you have connected though might not. Okay, that looks fine. Ah, but it works now. Cool. That's awesome. Well, that's the nice thing about DIY. And I mean, I guess it's a closed source design, but because I share everything you need to build it, it's pretty easy to repair. For this new version, one of the things that will make diagnostics easier is because I will also be sharing the net. I will be sharing the IBOM, but I'll also be sharing the net list basically. So if you're like, okay, what is this pin connected to? Of course, it's not showing up. Why not? Interesting. I figured that would show up. Is it because I ticked it off? No. Huh. Interesting. Oh, right. I thought, like, why isn't this showing up? Because this one is connected to a resistor, and then that leg of the resistor is connected to another pin. But here you can easily see, like, if you push this pin, you see that over here it lights up red too. And if I push here, it lights up too. So you can actually trace where everything is connected by pushing on the pins, basically. So if you push on ground, you see that ground is everywhere on the board. But if you push over here, you see that this is shared, and then it goes to these pins, etc., etc. So once this version is out, I will also release this IBOM file, and that will make certain troubleshooting also a lot easier. Hey Sion, welcome. Let's see what we did already. We did the fuses. Is it only terminals now? Alright, well, we'll do this last. That's fine. I guess we should do the pin headers. Yeah, well, it'll make it easier to reverse engineer it, but it won't show the exact tracks. So, although they could, if they really wanted to, figure out how it's all connected. Well, you could do that anyway. It's a two-sided board, so you can see all the traces. It still doesn't really show everything that went in there in regards to layouts and stuff like that. So let's get some pin headers. When, please? I don't know yet. Well, I'll be testing this one after we're done. Philip has one, and Andy has one, my Discord mods, and they'll be testing it too. And once we iron out all the bugs and the inconsistencies and other stuff, I'll release it. And it'll be slow. I won't do I've decided that I'll release it before I release a new soldering video and stuff like that. But using the IBOM, it just makes it a whole lot easier. So it's a loss. Oh, why isn't this going in? Interesting. Hold on. Huh. It seems one of the holes has got solder in it. There we go. That should have fixed it. Somewhat. Hold on. Okay. Looks like one of the holes has gotten solder in it, but now it's at least stuck. Let's see, we need some pin headers here. Okay. Did I get solder in here too? No, it didn't. Oh, some of these holes aren't perfect. Did you have trouble getting the pin headers to go in, Philip? Seems my PCBs are either out of tolerance or very tight tolerance. I'll have to check that in the design file. Let's see, these go in easily. Yeah, I have to really push those in there. Although these go in fine, just again. I'll make a note of it. Just check that out and maybe enlarge the hole spacing a little bit. Okay, let me make a note real quick. Check hole size, Q pins and such. Okay. I believe these are all the male 2.5 millimeter pins we need. So that is those. And this guy and this guy. Yeah. Okay, let's see if the board flipping still works. Should. There we go. Flipped it. Now I'm gonna again tack each of these pin rows, one of them. Okay. Maybe the connector? Yeah, but I've used these pins for most of the builds I've done this year. So, I'm not sure. Maybe I used a different hole size than I normally do. Well, I'll just check it. So, these look straight. Oh, there we go. These look pretty good and straight. These are all slightly bent. So what I usually do is I put my finger on them. Now, mind you, they do get hot. So you have to be quick about it. Ow. Okay. Damn it. Oh god, now we're gonna have a problem. Because it came out because it was too hot. I wasn't quick enough. But now, of course, it's gonna be a tough task getting it in again. Let's see if I can do it. Almost there. Might need to think of a different way for this. Those 4x2 pins is what I used for that. Okay. Not sure what you mean, Philip. I didn't get it when you mentioned it either. Let me try and fix this. Put a female header on the middle pins. Oh, okay. I can try that. Where are my female headers? Not over here. But I'll need them in a bit anyway. So let me get my box out. Hold on. My female headers are in the dating app. So, I think we need one of these. Let me check if these are the right size. Yep, okay, that's good. And then on the other side, we need the single-spaced ones. Oh, these are also double. double. There we go. Okay. So the trick Philip mentioned was putting them like that. Okay, but then how does that straighten them out? I guess I should have done that to start with. Let's see if that improved it. Well, okay, we don't need that one right now. Yeah, they're still a bit crooked. I guess I should have done that to start with, huh? So I'll try and fix it my way. That's one. That's two. Slightly down. And the last one. Okay. Yep, that should be fine. No, the last one actually isn't. Hold on. It'll do, I think. Let me see if we can line them up that way then. Not really. Okay, let's see if I unsolder this right now. Might need to think of a different way for this because this is difficult to solder. Okay, let me just tack them in fully. There we go. So this T3A soldering stand has one issue. It has this, metal shavings that I use to clean my soldering iron, and that works great because you can wipe it off like that. But it has this crummy mechanism that's supposed to hold it in, but each time you wipe off your solder, it basically comes up. So let's try if I can put a rubber band on there. To basically hold that down, because it's really starting to annoy me. Okay, well that's one rubber band. I have another one. Let's see if I can put that on there too. There we go. There. And now I can just put it in there and do all kinds of stuff. Take it out. Perfect. Great. Finally. Okay. Yeah, the new boards are just to improve compatibility with Ethernet and some input stuff, and there's some rearrangements and things like that. But it's mostly to get back in line with the current pre-assembled boards. But in regards to real features and current handling or something like that, they're slightly improved because of the PTCs here, for instance. So they're slightly safer in that regard. But overall, it's still the same board with some tweaks. And if you have the V1s and those are working fine for you, there's no real reason to upgrade. So, yeah. I mean, we're moving away from the linear converters to a buck converter and stuff like that. But it's, you know, more convenient things. So, we now have this guy, and this guy. And I think it's now screw terminals, and then the socket here, or no, then these. Yeah, okay, well, now the order I don't think matters too much anymore. So let me get some screw terminals. We'll need a 3 here. Another 3. No, 2 2s. That should be those. Then over here we need a 2. Burgratz, thanks for the donation. Thanks for your work on the Queen LED Dig Uno. My pleasure. There we go. But thank you very much for the appreciation. Okay. Then we need a blue one for here. And we need 2 of these for over here. And that leaves, oh, we need a 3 one here. Let's splice these together. And these. Those go later. Oh no. Okay. Let's tack them in. Okay. Those are all flush. That's good. So we need to do this guy. No, I mentioned the super chat, Philip. Go away, Windows Defender. Okay, that should work fine. Thanks for your girlfriend for distracting you. Yeah, that's okay. Oh, I just noticed we forgot to do something. The male pins we stuck in and we tacked them in, but we didn't solder them in. So let's do that real quick before we forget. Oh no, I created a bridge. Now I created another one. Should I have changed my tip? Maybe. There we go. think that's okay. Yep. Oh, didn't solder that one yet. Okay, let's solder the rest of the pins because everything was in straight enough. I like hearing that, Brett. That you use a mix of controllers, whatever suits the situation best. Yeah, I know I didn't check, but that one should be in straight. We'll see when we turn it around. And there we go. See? That's in pretty straight. Okay. That's looking good. These are all in and soldered. This is in and soldered. Yeah. That's looking good. Now, I think I'll do the DC-DC converter next. No, I'm going to do the ESP socket next. The trick I use for that is I basically plug in... Oh no. Okay. It's a bit tight. It's a bit tight. Might need to look at the tolerances for these. But I basically plug in a board and then I solder it on there. So I just plug it in like that, and that way I know my pins line up straight, and I can lie it on there, and I'll use something to shimmy it. There we go. And then I can solder the pins of the socket, and that way, you know, the ESP should always align with the socket. So we can double check to make sure. Yeah, I always do the temperature sensor last because most boards I don't put them on there, but we'll see. Oh no, oh wait, no. I can't take it out yet because I don't have enough pins soldered. There we go. See, and now the socket is perfectly aligned and also works great when inserting the ESP. So that's a little trick. No, I don't need to change it to a finer one. I like soldering with this big, chunky, chunky boy tip. Oh wait, I'm not actually showing you anything. Sorry. Okay, let me check that. You're doing well to take no notice of the others. You mean the other pins? Or the other soldering tips? So let me check to make sure that's okay. Flip solder mine please mate lol. What? Yep, that looks fine. There's one that has a little spike. There we go. Okay. That looks fine to me. Yep. Okay. Then I think we do the DC-DC converter. Yep. There we go. And it should be V in on this side, because it says V in on the board and it says V in on this little module. So we can line that up. And this is something Philip already noticed. It basically sticks out a bit too far. I need to see what I can do about that. So yeah. Okay, let me solder one of those. There we go. And then straighten it out. Oh. Let's see. That looks pretty straight to me. Yep, that's good. So then we solder the rest. Yeah, I'll have to look at the silk screen, Philip. I might move some more stuff up here. But yeah, it's pretty crowded already. So I'm not sure how I'm going to do that yet. I guess you can still read it, but it's not great. Okay, well, I'll figure that out later. Big terminal time. I guess if I'm not going to pay attention to the I-bomb anymore, I should just put it away. Okay, let's put some giant terminals on there. See if I can shimmy this somehow. Well, somewhat. That's a bit much, but you know. Let's check alignment. So the positive one is on there pretty well, but the negative one's sticking up a little bit. Okay. Now, it gets hot when you touch the board, so let me try and see if I can do it this way. I think that got it. Yeah, so now it's flush with the board on both sides. And I can solder the other leg. Yeah, I should have done the DC last. But I was a little bit worried that I wouldn't have gotten the spacing correctly. So then I would have had a hard time putting in the DC if the terminal was already on there. But that doesn't seem to be the case, because you only solder it from the back, so that's fine. So DC converter definitely after the screw terminals. But these are on here now. Yeah, it's just slightly larger. Or higher. But it worked. Okay, now we have the cap left and the temperature sensor, although I'm going to forgo the temperature sensor because I know that works. Let's see what kind of cap I specified. 12.5 millimeter, 35 volt, 1500 UF. Okay. Let me close this drawer. Let me find one. Hold on. Because I have a box, and this box is called Big Capacitor. 12.5, 35 volt. Yep. So let's use some of these. This is also one that will be different from the original DIY dig quad, because it needs to be able to handle 24 volts. And the original dig quad didn't handle 24 volts, so its capacitor didn't either. Okay, I'm just gonna solder one leg. I'm soldering the easy leg. we go. Now that's... Oh, I was going to say, that's never going to be in straight. But that's in pretty straight. Yeah, that's fine. I can live with that. Well, Philip, anything at least 33 volt, because you want to support 24 volt in, and 1000 UF or higher, that should do fine. So this one is 1535 volt, but yeah. Let me snip those off. For your OCD, the R1 text is upside down. Oh, this one? Wow. You are very correct. I'll change that. There we go. Well, I made a note. I mean, not changing it right now. Okay. Thank you very much for that. Those are the things I sometimes don't spot, and then it needs another, another revision. So, let's see here. We have our terminals. Yeah. We have our DC-DC converter. We have our input voltage selector. Terminals. Capacitor, fuses. We can plug in a random Quinled ESP32. Yeah, that fits great. Okay. So, regarding the power selection, that's still with jumpers, but now we have a few more selections than we used to have. No more noise. So, the extra selections we have is basically, well, you can't see it on the board anymore, because basically the top jumper pair sets it to main 5 volt, and then the other one below that says VEXT, and then 5 volt. So if you have VEXT 5 volt coming in instead of main 5 volt, you want to use that. Then it says main 12 to 24 volt, so then you can use the main input for all power, and anything above 5 volt, and then it says VEXT 12 to 24 volt. So then again, you use these inputs to input the power, and then the main input can be whatever. Yeah, this needs to be clarified. I just ran out of space. Yeah, so for a button, there is also a... Let's see if I can focus better on that. There we go. A button pin. So next to Q1 and Q2, there is a separate button pin which is connected to GPIO 0, which also already has a pull-up resistor, because that is this guy over here. Pull-up button. You can't really read it. There we go. Pull-up button. So you use that pin, the button pin, and a ground. So for instance this one, and you connect the button in between those two pins. That's it. I guess we should test it, huh? Let me get a jumper. Do I have a jumper somewhere? Oh wait, I have a box of jumpers. What color jumper do we want? Do we want a black jumper? Do we want a white jumper? Do we want a green jumper, a blue jumper, a red jumper, or a yellow jumper? Personally, I'd go with a red jumper because they're selecting voltage, so they're important, so red. But what do you guys think? Let's vote. What color jumper do you want? Yellow, red, blue, green, white, or black? I don't have a pink jumper. Yellow. Black. Mint green. Is this mint green? Red. Now we have 2 red. Black. I think that's black, but okay. We have 2 red. Oh, yeah. Oh, we have 3 red. Black, black. Okay, 3 black, 4 black, 5 black. I think the blacks are winning.
Remember all the happy times we had?
Yeah, I think black is on 4. Okay, that's fine. There we go. I don't have pink, and he's not even here anymore. So we're going to be using the board with just the normal main input terminals, and we're going to apply 5 volt because I can use my testing bars. So I'm going to be putting it on main input 5 volt. That's it. Easy enough. Why is it crooked? How did that happen? Okay, the pins are just crooked on there. Well, you can say red 5 times, Draadstaal, but yeah, it should be red. I agree. But now I think we have enough reds to move it to red. Let me see how red looks. Because I've always had a red jumper on the voltage stuff. Yeah, I think that looks better. Sorry. The reds have it. The reds have it. Ow. Ow, damn it. See, that's... I forgot the drawer was open. Anyway. We might actually blow this up during this stream. Who knows? So, main 5 volt should, enable main input 5 volt. That's it. No more jumpers needed. Don't apply 12 volt. As some of you have noticed. That's... Ooh. Damn it. That still works the same way. Okay, hold on. I need to... Okay. I think so. Yeah, okay. I think I managed. Or mains. Yes. Stubbs Christmas is very right. Do not apply mains voltage to your Dig Quad or Dig Uno or whatever. Pre-assembled, not pre-assembled, DIY. Just don't put mains voltage on there. And you'll think like, are you an idiot? Who would put mains voltage on a Quinled board? And then I'm like, well, there have been a few occasions people have done this. And then they're very happy the protection mechanisms are on there because nothing spectacular happens. Aw. Okay. Let's program this with the newest WLED. I guess we'll need some of these in a minute. No, we don't, because we're using testing bars. Okay. Check the Discord. What? Hold on, I'm just gonna program a Quinled. I'm not gonna show the installer. Install the WLED.me. Well, I guess I could show it because it's right here. Check the Discord. Hold on. Oh, not now. Yeah, okay. Yeah. We've had people put mains voltage on there before. Okay, so we're installing WLED to this Quinled module. Takes a little bit. Yeah, it's a nice song. guess I should start cleaning up already. Assuming everything works. We're just gonna assume that. That was a Coke Vanilla. Hold on, let me clean up real quick. So yeah, Coke Vanilla. Coke Vanilla. Where is it? There he is. Vanilla. So, Stubbs Christmas. All this music is from Approaching Nirvana. You can find it on YouTube or on Spotify or something like that. He makes awesome music. Thanks from your wife. Okay. Okay, let's get it connected. It's so awesome you can just do it immediately. Visit device. Yeah, there we go. Okay. ESP flashed. So, let's prepare the load bars, but I need to clean this up first. Hold on. Let's put this out of the way. Let's get 4 load bars. It's not sticky anymore. Okay. Kind of want to wire those up in order. Whatever. Guess I don't need this anymore. My main intro tune, it's from, well, it's in the description. I forgot his name real quick. So let's wire these up. This one goes here. This one goes here. New releases I'll probably just do on PCBWay because I like their service and quality best. I used to do dirty PCBs and PCBWay, but it's a lot of extra work, and generally now PCBWay is as cheap or cheaper. So then I'd rather work with that than have 2 places basically that I have to support. Okay. Power wires. Hey, it's J After Dark. I have to open these up. Oh, he doesn't want to use PCBWay. Oh, okay. Okay, then I might need to reconsider that. I didn't know there were reasons not to use PCBWay. It's an updated version, yeah. But it's the same board, it's just a much newer revision. Actually, the one behind me was a very early prototype. Hey, Jay After Dark, $3, no message. Thanks a lot, man. Appreciate that. Yeah, there should be a fire extinguisher here somewhere. Oh, there it is. Yeah. From last stream where we started welding with fork terminals. Because we were testing fuses. Yeah. Let's use some of those fuses that don't blow until above 190 amps. Yeah, those are shit. Yeah, but I can't support JLC PCB. I haven't had the best experience with them myself, but other than that, they don't have a system for sharing PCBs. So I'd have to release the Gerber files again, and well, I don't want to go back into that nightmare, so yeah. That thing from 2016? What? Hey, Mr. Blue. Yeah, it was a surprise live stream. I already did a video and thought, I want to solder a board, so let's do a live stream also. Okay, that looks decent enough. Let me put these like so, because otherwise, no, not. Yeah, I guess so. I'll just blind myself. No, put them up. I don't want to blind myself. I'll blind you guys. Okay, we need a power supply. I think that's going to be this guy, because it's 5 volt and has 80 amps, and it's passive. But I'll need some cables for that. Nope. Where's my screwdriver? Should be here somewhere. Oh, I'll use this one. Okay, let me get that screwed in. Okay, this is 2 times a set of 12 gauge, or 10 gauge even. That should do fine. So left is always positive in this board and right is negative. It's a updated design of the Dig Quad DIY version. Oh, interesting. I order, I'm not going to say every 2 weeks, but at least every month from PCBWay, and I don't have any special account or something like that. Never had much issue with them. And I mean, I've ordered dozens of orders from them. Not like 5 or 10, dozens. So, yeah. But I mean, everyone's experience is valid, of course. That's their experience. So, I mean, not trying to discount that, but, yeah. Oh! This is our soldered fork terminal. Well, can't use that one. Have to recrimp it. If you were there the last stream, you know what that's about. Or a welded fork terminal, I should say, actually. Okay. Oh yeah, for shipping, I do often use FedEx, and if I can't otherwise, I use DHL. I don't use the cheaper shipping options because generally, well, I need it quicker because otherwise all these prototyping stuff takes even longer, so... But then it's probably more a shipping issue than a PCBWay issue, but sure, okay. No, I didn't run out of fuses. Speaking of fuses, we'll need some fuses. Let's act like it's a pre-assembled board and put in the same fuses as those. Because I actually have a bag of those. There we go. Okay. That's a weird looking Dig Uno. That's because it's a Dig Quad and then a V3 DIY prototype. So to update the DIY model basically. Okay. Positive to positive, negative to negative. Yep. And let's see which plug is in my AC socket. It's not the right one. There we go. This one, I think. Yes, that's good. Move that out of the way. I'll put it this way. Let's hope the LED's in the right way too. We'll be switching to this view, and we can't see one of the bars. There we go. Okay, it's a little bit of a cable mess, but that should be okay. This looks fine. It's set to main input 5 volt. This is a 5 volt supply. Should we put my the pre-assembled had a very small batch the first time on PCBWay, and then I switched to AllNet, which we've been using ever since. Yes, this is going to be a DIY board. Or this is a DIY board. We just built it. Okay. Let's let's turn it on and see what happens. I put my glasses back on. You never know. It's drawing 7 watts. That's a bit too much. And nothing is turning on. Did I make a mistake? Did I blow something up? No. No, but the LEDs also didn't turn on. So neither the LED of the board nor of the ESP32. So there's probably a short somewhere. Did I put in the capacitor wrong? No. Okay, I'm going to turn it back on and then we have to measure some stuff. Smoke cam should be on the big screen. Yeah, we're not doing smoke cam today, I hope. But we'll see. So turning it on again. Power supply is on. Power supply is outputting 5 volts. Okay. Are we getting 5 volts on the inputs? Yeah, we're getting 5 volts on the inputs. Okay. So there's 5 volts on the input pins. Is there 5 volt on the output pins? Okay, let me switch back to... There we go. So let's see if the outputs are all giving 5 volts. They are. Okay. Then I might have made an error in my jumper stuff. So we're getting 5 volts in. Okay. So let's turn this around and see if that is working as expected, or maybe the PTCs aren't working. So here's ground. And okay, this pin has 5 volt on it. I'll zoom you guys in. But then you can't see the multimeter, but yeah. So input power is here, and that is 5 volt. Yeah, okay, hold on. So then this PTC has 5 volt, I hope. Yeah, and on the other side. Yeah, it also has 5 volt. Yeah, this is going to be a tight squeeze there. Okay, so this should have 5 volt, and it does. This should have 5 volt, and then this should have 5 volt, and it does. This should have 5 volt. Ah, and this doesn't. No, it also does. Okay, this has 5 volt. Okay. Alright, I think I see the issue. Why is this diode here? Not sure that diode should be there. So after the PTC we get 5 volt. This diode has 5 volt on one side. And it has basically nothing on the other side. No, this is getting 5 volts. What's going on? Is it hot? No. No, it's not, because that gets its power from here. We can check if the LED is... Or well, this is the LED resistor. That's showing 5 volt on this side. And on that side. Okay, I'm confused. Hold on. I need to check some stuff. It's positive. So this should be... Okay, at least the LED's on there backwards. I think. Let me check in diode mode. So now we can make it beep. Right? But we can also check if an LED works. Right, so negative on this side, positive on this side, and if we do that, it lights up. Okay. So that is the way I thought it would be, but then is this connected? No. Yes. Okay, so the LED is on backwards, or at least not the way I intended it to, because this side is ground, and this side is positive, and the LED has it exactly, or well, the LED is on that way, but the pads are not connected that way. See? So if we do it this way, this side, this is connected. So ground is on this pad, not on that pad. So that's at least wrong. So let me correct that, or let me just take off that LED just to make sure. This is off, okay. I need to correct that in the design because that's not logical. Okay. Well, let me take that LED off real quick, because that will annoy the hell out of me. Let me remove this tip. Remove this tip. Yeah, reverse LED can cause issues. Sometimes it does, sometimes it doesn't. It's a bit unclear. But I at least want to correct that. So let's see if we can turn it around after we've soldered everything on already. It's going to be a bit of a challenge, but okay, I need to undo those wires. Yeah, we'll check WLED after this, because the board might actually be coming online. Just for some reason, all LEDs aren't working. It's kind of vague. But let's get this off first. Okay, yeah, I'm gonna use the big tip for this. Yep. because I'm just going to drown the board in heat. Okay. So let's turn that around. I think that did it. Okay, that should have done it, I think. Oh, the desk is a mess. Okay. Yeah, I'm confused about the ESP not being online, but we'll check further later. This is at least one mistake we needed to correct. I think we did that now. So let's verify that and then continue troubleshooting. Okay. Okay, so let's turn on power. Right. Okay, now we at least have a board LED. Good. So I need to fix that in the design because that's not logical. Right. So now let me check my router if it came online. Because we configured it during flashing. And it doesn't seem so. So I believe the ESP is still offline. And I think that might have something to do with that diode. Because I'm confused about that diode even being there right now. So let's check what is connected how. So this diode is connected in the positive path, okay. Confused. It's of course great when my brain wasn't working anyway. That's not right. Okay, so power comes in, we jump right here, we go to the PTC, go here, but then it gets blocked here. That makes no sense. I'm gonna remove that diode. Something tells me that shouldn't be there in that fashion. Yeah, it might be backwards, but I'm gonna remove it first and then I'm gonna meter some stuff and then turn on the exhaust. There we go. That's off. Okay. Still in diode mode. So let's see here. This should be connected to that. It is. Right? But then this is also connected while it's not even on there. That doesn't make sense. Let me remove that jumper real quick. Okay. Okay, now this isn't connected anymore. Okay. So let me check what's connected here. This is not connected. That's good. Yeah. I might have made an error in design. It's the red jumper. It should be black. Yeah. Yeah. What did I do? Let me check real quick. Yeah, I agreed, G. Peters, but I'm not sure what I did to cause that. Sorry, yeah. Just looking into what's going on here. So if we have V... Thanks, Melvin. How does this thing work without transistors? Well, it's a digital LED controller, so it controls it by a digital signal. Okay, so VCC-F goes here. And then it connects as 5 volt. And this connects with that over there. Okay. Why is this diode here? Oh, okay. I know why that diode is there. Okay, okay. Yeah, yeah, yeah. That diode's actually fine. Sorry, let me figure this out real quick. Yeah. That's good. Yeah. Okay, I might have accidentally crossed a via while soldering. Let me try and remove that real quick. Okay. So let's check. This should be ground. It is. This should not be ground. This should not be ground either. Okay, that's good. So this should be in contact with this pin. Not with that one because we need a jumper. But it should be in this one. Yeah. So ground, is it in contact? No, it's open. Wait, what? So ground is somehow connected. Yeah, but it's these. Yeah, okay. Interesting. I'm gonna try it again. Without a jumper on there. Shouldn't do anything. But let's see. Yeah, okay. Not doing anything. That's good. Because there's no jumper on there. Okay. Let's put that jumper back. Okay. I don't get it. Let me measure some voltages. Oh, what? I'm getting 5 volt in on the DC-DC converter, or on the LDO. I'm so confused. Yeah, there's 5 volt coming into the ESP. Is my LDO somehow broken? Ooh. We got another ESP. For some reason, the board LED now isn't working anymore. Let's try this one. Nope. Okay. I'm very confused. So that wasn't it. Did I put the jumper on right? Yeah. So we seem to have a connection between positive and negative. Yeah, I don't think it should be 37 ohms between positive and negative. I don't think there's any bridges. Well, this is why you do prototypes. I don't understand what went wrong. I'm not sure it's pulling power, but we could use the FLIR to see what's going on. Yeah, I'm not sure what you'd want to measure on yours, Philip. It's almost time for the backup to start again. We had an issue with that last week. Let's see what it does this week. Okay. Let me get the FLIR up and running. Okay. Yeah, I'm not going to be able to show you the FLIR and the board. So I'm going to show you the FLIR, I guess. Yeah, okay. Turning power on. Now let's see if something gets hot. Not seeing anything get hot. And if nothing gets hot, that generally means we don't have a short circuit. And the power supply also doesn't think we have a short circuit because, well, it's still on. If there'd be a short circuit, it would turn off. So I'm starting to wonder if I use the wrong components. Oh, wait. Okay, so there is a hotspot, and that is the LDO on the ESP32. Which is normal, because that's dropping from 5 volt to 3.3 volt. So the circuit is actually working because power is getting to where it needs to be. I think I might know what could be the issue. I'm starting to wonder if I used the wrong PTC here. So it's getting power, it's just not getting enough power. Because it's getting limited in how much power it can draw. Let me check that PTC back. Although I'm not sure I can find it because there's lots of bags. So that was a 1206, I think. 750 milliamp. Yeah. 6 volts. Yeah, I used these, that's for sure. And these say the same thing, so that JA. But I'm wondering if these might not be up to spec somehow. Let's replace that. Or maybe this is a bad one, who knows. Let's replace that for a different version I have, which is a 1 amp version. Yeah, 1 amp, 1 and 1.1, 750, that's all basically fine. Okay, let me try and take that off. That one is off. And now let's try and put the other one on. I'll get some extra solder. Ah. It's not a JBC, it's a Ixun T3A, but it basically works the same and it's excellent. Okay, that should do it. But yeah, I really like it. Yeah, the clone, yeah. It's excellent. Lots of power. Heats up really quickly. Okay, so we replaced that PTC. That looks fine. Now I'm wondering if this LED was on there correctly all the time. Let me check the PCB file. No, okay. It's actually not. Yeah, I actually have the LED on there with ground on this side. Okay, that's stupid. Well, anyway. Then this should now be in the correct position, I think. Let's see what it does. Doesn't do anything. What is going on? I don't understand. So, we have some ground over here. Five volts. 5 volts. 5 volts. 5 volts. 5 volt. 3-hour live stream. Thanks for the donation, Draadstaal. Oh man, what's going on? Why doesn't this work? What is causing this to fail?
They talk about another kind of world.
5 volts.
Another kind of world.
What are you afraid of?
I don't understand.
I'm lost in old ways.
I'm not afraid.
Just listen.
Right. I don't understand why the LEDs are not turning on now, because this... What? Yeah, that makes no sense. 5 volts. Yeah, 5 volts on the LEDs. I guess I could unscrew the LEDs to make sure that those are not causing the issue. Can't imagine they would, but... Okay, so let's disconnect all the positive leads of the LEDs. There we go. And now let's turn it on. Didn't change anything, it seems. Okay. Well, there's less power draw, but that's normal. It's to be expected. I must have made a mistake somewhere, but I don't understand where. It's officially the 2nd of April, so the joke's over now. I wish, man. But there's no joke. I really don't understand what's not working. I'll figure it out eventually, but... yeah. Yeah, I heard about it. That's actually a friend of mine who worked on that. Yeah, I'm thinking about that. It shouldn't make a difference. But I guess we can try. So let's try using 5 volt EXT. Yeah. So we're gonna try putting 5 volt on the 5 volt EXT and see if that at least boots up the ESP somehow. Let's see with what wires I'm gonna do that. I'm just gonna cheat it. I'm gonna cheat it. Maybe I missed a component. I don't think so, but it's always possible, I guess. So I'm doing something I don't advise anyone else doing. But I don't want to get another power supply right now. Let's disconnect this. Okay, that should be fine. So I've screwed it into 5 volt EXT, and yeah, this is kind of janky. As I said, I don't advise anyone doing that, but it'll work. So 5 volt goes into 5 volt EXT, and then ground goes into ground. Oh, good night, Mr. Blue. And let's see what happens. Nothing. I'm so confused. How did I botch it up this bad? Because now, if we put it in continuity mode, and we beep it out, this PTC should now be connected with this guy. And it is. And this is connected to here, and this is connected to here, and this is also connected to the 5 volt in pin. Which is fine, which is correct, which works. It'd be no fun if everything went right just all the time. It doesn't. Except normally I do this off stream instead of on stream. Did I solder a resistor somewhere where there should be a cap? No. But this LED thing is troubling me. Let's remove the ESP. What missing? Oh, this one? Yeah, we removed that earlier in the stream to diagnose. That shouldn't be the issue. So the LED, what is it supposed to be now? Front view. Okay, that one, that side's supposed to be ground. Yeah. So it's supposed to be the other way around, as I had it. No, is it? Okay, I'm gonna resolder the LED. Yeah, I'm not sure this is a cold joint though. But I'm gonna remove it anyway. It was on the right way. Because I verified, and this side of the pad is ground. Although it should be this side, but that's just stupid on my part. Let's I don't know, let's check it without LED. Okay. Yep. 5 volts. So just to make sure which pad should be what on the LED, that one should be positive, and this one should be. I can't see the multimeter still. I don't know where to put it. Sorry. So this one should be positive, and this one should be negative, and it is. Okay. So yeah, the LED was on correctly, but something else is causing an issue. So I believe this is, yeah, even that works. So this is the pin that supplies the 5V in for the ESP, and even that works fine. No, it's current limited, but that's fine. Yeah, these are now all off. That's correct. Well, that's not going to do anything. This is 5 volts. Yeah. It's working as it should, except it's not. Okay, let's go back to main power. This didn't solve it. Well, I guess I should resolder that LED. If I can. Let me try and resolder that real quick. Oh. I think that's on. Oh wait, I need to check the jumper. I guess we could put it in diode mode and measure the inputs. I don't know if that's going to work. Okay, that should in theory work. And it doesn't. Why? I don't understand. Okay, we're going to beep it out again, right? So, we have our positive input that's connected to this PDC. That's correct. PDC works. Yeah, okay, that's connected to here. That doesn't do anything because it's not bridged. And it's connected to here. That's correct. Then it jumpers to here. That's fine. Then it goes to this PDC. That goes into here. That goes here. That connects to here and here. And that goes here. That is all correct. And if we take ground... Yeah, see, this is the issue. Why is ground connected to positive? That makes no sense. It's also only somewhat connected. It's not perfectly connected. So this is ground to ground, and this is ground to... What? Makes no sense. Yeah, I don't know. I mean, it's possible I made a mistake, but I really don't understand where. I think we can all agree that plus and ground should not be connected. Oh, measure it without the PSU connected? Sure, that's a good tip. So, let's see. Oh, that's a good tip there, Philip. That is correct. I guess I should unscrew everything from the LEDs too. I'm not sure what you're writing there in caps there. It's shouting too hard. It did not go bang. That's good enough for me. No, it needs to work. Okay, no wires, no wires. There we go. So let's beep that out again. We've got positive and negative. It's beeping sometimes. I don't know. Well, it's getting some volt. Of course, there's diodes here. But those are not supposed to let anything go through that way. Oh, my diodes just complete bust. Yeah, so from this side to this side it's allowed to go through. That is correct. And then from this side to this side it's not. Yeah, that is correct. That's fine. Okay. Yeah. Let's do the fuse. I don't know, man. Is this cap bad? No. What? That's wrong. How annoying. Wait, what? That's not correct. Let me check something. So there's a cap here for the 3v3, and this should connect, but that certainly shouldn't connect. And it's supposed to link to ground here, which it's also, but it's forming a bridge. Okay, let's remove that capacitor. Yeah, sorry if I'm not paying too much attention to chat. I kind of tried to figure this out. I'm going to try and remove one capacitor and see if that solves it. As I'm wondering if that is causing the issue. Okay, I made a giant mess of that. But let's fix that. Might need to get the flux out. Yeah. Come on, stick to those pads. Okay, I'm gonna get the flux out. Yeah, I know. But I always try without, and then I'm like stupid, you know, and use flux anyway. is if anyone's interested in the flux I use a Chipquick SMD 4300. It's water wash, no clean, so that's excellent. There we go. That should fix that. Yeah. Now this will smoke. Okay, let me check. Okay, that should be fine now. Let's see if we can beep it now. Okay. So let's see. We have 3v3. Should be connected to this one. But not this, and it is. So let me show you up close. So we have a cap here for 3v3. Come on. Okay, stupid wires. Starting to get annoyed. That's never good. Okay. So we had a capacitor there. And if we probe 3v3, that's connected to this pad. That says beep beep beep. So that's good. But this is ground. So somehow ground and 3v3 are connected. So this is a ground pad. Okay, let me check on the schematics where 3v3 is going. So 3v3 is also connected to this resistor. What the? Or it's not. Okay, it is, yeah. And on this side. But is it then also connected to ground? Yes. That makes no sense. Okay, let's see where 3v3 is going. Okay, we also have 3v3 at the temperature sensor. And that's over here. Okay, I don't know what you guys are seeing. Okay. Let me do it that way. So we have 3v3 here. So that's never correct. It shouldn't read 3v3 on both sides. Okay, so let's remove those. I don't know. They shouldn't be jumped, but let's try and remove this capacitor. There we go. Is 3v3 still connected to ground? Is the question. So now I removed that capacitor and 3v3. It still is. I'm sure you guys can't hear the beeping. Sorry. Let's see. Can you hear the beeping now? Beep beep. Now it's beeping. Okay, so there is a resistor there that's also connected to 3v3, so let's remove that. And let's try it again. Oh, you could hear it. Okay, that's good. Okay, so 3v3 pad to 3v3 and ground. Okay, so this is now not connected. That's good. So 3v3 is still connected to ground somehow. Why is it still not? Okay, there we go. Okay, need to find more spots where 3v3 is, I guess. Oh, right. All the pull-up resistors are 3v3, so let's remove all the pull-up resistors. So that's, for instance, these. Yeah, I could do one at a time, but I'd rather find the issue and then figure it out later. Okay, so this one was never connected. See that? That pad is fully dry. That wasn't soldered on properly. Still, that shouldn't cause an issue, but, you know. Come on. No, not more bridges. Okay. Okay. Now let's see if beeper goes off still. 3v3 is still connected to ground. Okay. Oh, there's one more. There's one more. Yeah, sorry I forgot that one. But I got it now. Okay. So this pad is 3v3. 3v3 is still connected to ground. Yeah, so the problem is I had five of these PCBs. No, I actually have one left. That's a good idea. Let's try that next. Let's try that now, because I'm starting to run out of ideas here. Okay. So this is the exact same PCB. We're trying this pad and these. That's good. Huh. That's not good. So this is a 3v3 pad. Ah! That was an excellent suggestion. Sorry for the focus. Too many power trips here. Okay. PCB design fault or PCB manufacturing fault. Because, yeah, so this is 3v3. That's good. How? But there's never a connection between... I figured it out. It's a design issue. Damn it. Okay, let me let me share the by high exception the KiCad file. Hold on just a second. I found it. See that? That red line is this 3v3 line. And those vias are ground vias. Well, that explains a lot. Oh man, how did the DRC not get that? I don't understand. The DRC should get that. I mean, easily. Let me run DRC. Let me turn that off real quick. Sorry, I just don't want to share that too much. Let's run the check.
Remember all the happy times we had?
Well, okay, DRC does get it. But I always run DRC before I send off to manufacturing. So no clue why that's in there.
Remember all the happy
Huh.
times we
Well, okay. Still, I mean, let me go here. So, still, although this board is clearly a failure, because that's never going to work, this whole exercise and this prototype is, in my opinion, still a success. Because, well, that's why I do prototyping. We learned some stuff from this prototype. For instance, this island here with the jumpers. I need to see if I can re-engineer that to make it a bit more clear. All tolerances were fine. All components fit together and didn't cross and stuff like that. And, well, everything else beeped out the way I expected it to. And then, I mean, why this isn't a failure is because you make prototypes to catch these issues. So, yeah, so this isn't ready for release yet, basically. There's a few little things I want to work on. Like, as I said, those voltage jumpers could be... Maybe I could think of a better way. Make it easier to solder, or at least better to read. And I want to flip that LED around, because that's just stupid. And, well, fix the issue with 3v3 crossing ground. We could actually test the board. We could actually no, okay. Yeah, we could. If I snip off the 3v3 pin on the ESP32, there won't be any 3v3 on the board anymore. And then the rest should work. No. I don't think a bot would do it, because 3v3 is everywhere on the board, basically. But if I just prevent 3v3 from coming in by snipping off one of the pins on the ESP32 itself, that would do it. Yeah, let's for science. For science. Let's do it. Let's do it. So looking here, we have our 3v3. That is this pin, right? So 3v3 is here, and 3v3 star is there, but we're not using the star on this board because that's a, you know. So I'm gonna snip off this pin. Okay. Now I need to remember that. I'll probably mark it with a giant marker, because otherwise I'm gonna plug this in other boards and be like, why isn't it working? What's going on? Okay. Anyway. So now 3v3 is still connected on the board to ground. Let me check to which it all is connected. Yeah, because we don't have the temperature sensor. We removed all the pull-ups and pull-downs. Okay. So that should be no issue. So in theory, if we now plug it in and wire it up, you want to know something interesting though? I think the Quinled ESP32 actually saved the board. Because the Quinled ESP32 module, which is generating the 3v3, has a PTC on there. So it's not allowed to draw an unlimited amount of power. Because we basically created a dead short between 3v3 and ground. It would have drawn unlimited power. But because the PTC on the ESP32 limits how much it's allowed to take in, that likely saved it. Right? Of course, there's PTCs on this board too, but you know, all the PTCs together probably, you know. So, okay, positive, positive, negative, negative. I think the LED's on there correctly. We're on main 5 volt. Let's try it. Success. Well, the board LED isn't success, but at least the ESP is now online. Okay, good. Why isn't the board LED working? Am I stupid? Let me try it again. So ground is on this side. Yeah, that should work. Is it just not soldered correctly? Yeah, that might be a soldering issue. Let me fix that. Yeah, I'm not going to drill those vias. Those are way too small. Never going to get those. Let's see if that did it. Not sure. Yep, okay. Now we have a power LED and a ESP32 LED. Okay. So I removed pull-ups and capacitors. Now, capacitors are always a, you kind of need them. Until you don't, until you do. So, there's still, the level shifter capacitor is still there. That's the most important one. And this one's still here. That one's still there. Yeah. Okay, so the 3v3 capacitor is gone, and this one's gone because that's on 3v3 also. Yeah, okay, so we'll leave it like that. Okay, cool, cool. Oh, well, then we get to screw in all the wires again. Hey, and we're past 12 o'clock, and the stream hasn't crashed yet. Yeah, I think it'll work now. Philip, oh man, it's going to hurt getting up in the morning. Hey, but, you know, we figured it out. Thanks to hints from you guys, but still, we figured it out. It's strange though, because I am 100% certain I did a DRC check before sending off this board. So that should have always gotten it. Always, always. But it didn't. Well, it was in there now, but maybe I had a bogus beta version of KiCat. So any pull-up will need 3v3. The sensors will need 3v3. The button needs 3v3. So it's only a few things. And I'm actually pretty happy that even with a dead short between 3v3 and ground, basically nothing happens. Doesn't explode, doesn't die, doesn't, you know, react in any violent way. And that means the protection stuff is working. Now I could solder on the diode again. That is also a protection diode actually. But maybe I'll do that later. That's for now. I just want to see some LED output, and then I think I'm done with this stream. Well, we saw the LDO was hot, but maybe it was the LDO doing short circuit protection. Not sure. Sorry, you can't even see what I'm doing because I'm zoomed in way too much. Hold on. Right, main 5 volt, plus, minus, plus, minus, plus, 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 minus, minus, minus. That all looks good. Data wires. Okay, let's see what happens. Well, nothing, but... Okay, well, we've got something turning on, that's fine. Let's go to the IP address of that thing. 1024. Oh, right, we already had that. Okay, so that should be this ESP. Let's turn this off. I don't want any brightness limiters, and we want 4 channels. Those should be... Oh no, flux. Okay, 16, 3, 1, 4. They're all SK6812. And they all have 144 LEDs. Save. Ah! Will you look at that? We have 1, 2, 3, 4 bars of LEDs. What? What are we counting? Oh yeah. There's a few vias there. I didn't actually look in KiCad, but yeah. Let's see. Yeah, that's working great. Success! No. Oh, man. No, Sean. This is for the DIY version. The pre-assembled version is a, well, not by now I can say very different design. So that's not connected to this in many or any ways. Okay. Yeah, that worked great. Nope, not face. There we go. Yeah, that's excellent. Where's my Coke? I've deserved a Coke, I think. Oh, man. And here I thought I was going to screw up the soldering because I'm woozy AF. Because I think I'm partly sick. But, hey, we got it to work in the end. We had to snip off one leg. That's not bad. So, well, this is an easy fix. And as I mentioned earlier, the other things I'd want to improve or see during a prototype, well, you know, those are still valuable. And I'll do some other tests on it. But, okay, I want to keep it on screen because I'm just so happy it actually does something now. Philip, €5, now you can have one more cola. Wow, that's one expensive cola. But, yeah, that's true. Yeah, that's working perfectly fine. Excellent. ESP amputee, right? Oh, man. But it's working. Yeah, but so, I mean, this is what I do normally off-screen, working on prototypes. I make mistakes. You know, we all make mistakes. If someone tells you ever he never makes a mistake, well, I don't believe him. But the main thing is that those mistakes are not on the board once you release them. And, well, that's why we make these versions. Sadly enough, I sent these off to Philip and Andy also to test them. And, well, you can make them work. They just need a little fix. Where weed is cheaper than Coke. I guess I can take this off now. Damn, that was starting to hurt my ears. What is the status of the Dig2Go? The Dig2Go is full steam ahead. Okay, let's go to the face. The Dig2Go is full steam ahead. There have been some changes to the board, which are now working perfectly. I recently did a prototype of that. And, well, we're hoping to get that out somewhere in the next few months. It's going to take a while still. Yeah, sure, Philip. Using a QuinLED or a generic ESP is fine. Or you could modify the socket maybe. But, yeah, whatever else. Just make sure the 3v3 pin from the ESP board to the Dig board isn't connected, and that'll work fine. Send down the ground plane? Yeah. So I don't actually have a sneak peek because this was an unprepared stream. Yeah. Well, you know, you already saw the Quinboxed, but we are going to be playing with these guys at some point. So these are 30 amp relays, and this is an SSR or a solid state relay. We're gonna, you know, play with those a little bit. And I have that, let's call it competitor LED controller in. We could do some tests on that. And, I don't know. We'll figure it out. This was a good how to debug session. Yeah. I don't know about that. there could have been a more methodic way, I guess, to check it. But the best way to start is, checking every connections and if they're doing what you expect them to do. And once we figured out that ground was connected to 3v3, and kind of the LDO being hot maybe should have been an indication for that. Yeah. Competitor controller ripped it shreds. No, I either want to do a fair test on it and then try not to give too many conclusions of myself, or I'm not going to do anything on stream altogether. I'm not sure yet. It's a real stream. Oh, for sure. I just do not understand how this could have snuck into the PCB. Because if that line is there, you shouldn't even be able to place those vias, because KiCad will just refuse. And I always do a DRC before I upload the Gerber files. No clue. I have no idea. But, stuff happens, as you can see. I don't know if they check for things like that. I guess not. And I mean, in KiCad, they still have the other nets. Because normally what would happen if you placed a via there, it would become 3v3 and then not connect to ground. So I have no clue how this even happened. It might be because I converted this project from KiCad 5 to KiCad 6, and that something weird happened there. No, not in the Gerber file, but in the... I don't know. I don't know how it happened. It happened. Maybe your girlfriend did this for a peaceful night alone. My girlfriend is currently sick in bed with corona, so... I don't think so. It's also only 7 p.m. No. It's 4 past 1 in the morning here. So... each prototype costs, well, this was actually pretty expensive. Each prototype costs $40 or so, or for 5. Yeah, the girlfriend got it. And I'm still testing negative. I just feel like shit. So, I don't know how long that'll last. But, yeah. "1 a.m. Plenty of daylight left when you got LEDs." Oh, that's true. Look at them go. Well, that's not a very nice effect. Yep. Good night, Philip, and, well, I'm also going to be ending the stream. Thank you, everyone who stuck around and troubleshooted with me. I saw a few guys who helped me get to the right answer, so that's very much appreciated. And, well, I'll be making changes and improvements and see if I can, improve some of the stuff we also figured out during the prototype next to the crossed nets. And I'll be back with another prototype. And then hopefully we can release it at some point. So, Quinn LED University. That sounds good. So, thanks all. Good night. Oh, Draadstaal! Wait, didn't you just already donate that, like, a bit earlier? I'm scrolling up. Draadstaal! Are you gonna keep donating 10 euros every hour? You're gonna get poor real quick. But thank you very much. That is very much appreciated. I had no idea, but the journey was fun. Thanks, Stubbs Christmas. Yeah, can you imagine how I'm sweating in my bed when I order like thousands, make 1,000 of these PCBs? I have to be damn sure those are going to work. Because otherwise I'm like down, I don't know, 50,000 euros or whatever. So sometimes it's fun, sometimes it's a bit stressful. But, yeah. So, yeah, good night. Bye-bye, bye-bye. Thanks for watching.